Okay, so we had a question on assigning a projection to DTMs or DSMs that are created using CloudCompare. So to work through this, I'm going to download just a random LiDAR data set here around Blacksburg. And the first thing I'm going to do is download the LiDAR file. And then the second thing I'm going to do is download the DEM that's associated with it. In fact, it doesn't really matter which one of these you bring in. They're all going to have the same projection, and all I really want to do is borrow that. It's probably worthwhile to download the XML, just because that contains some handy metadata that you might be interested in. All right, so I'm going to pause the video while that's downloading. No need. Okay, so this is the LiDAR file. So this is the ZLAS file. And I need to convert that. So I'm going to use the LAS Liberator, or you could use the unzip file that was mentioned in lab. Both work just fine. Oops. All right, so we'll run the one with the GUI, and we'll open the file that we want, which is just again on the desktop, the one that we just downloaded here. We're going to unzip it. It doesn't really matter which of these you unzip to. This is the regular version. This is a another zipped format. So we'll just use the standard LAS file. Should just take a second to unzip, and you'll find that appear on your desktop when it's done. So here is the unzipped version, and I'm just going to go ahead and open that in CloudCompare. It is a good idea to make sure that this is set to 0. The rest of the stuff doesn't really matter so much. All right. So this comes in with a scalar field set to something else, just to make sure that this looks as clear as it can. I'm going to export that coordinate to a scalar field just so we can kind of see what's going on. If you look closely, you can actually see some odd signatures of scan lines and whatnot. Anyway, let's go ahead and run the rasterize tool. This particular cloud comes in as a referenced in feet, which I can show you how to find. We're going to update this grid, and I've got this set to a 3-foot interval at the moment. You can't see anything because it's all tied to that input value of 0, a base height above sea level. And so we're at like 2,300 feet above sea level, and that's why everything kind of tops out the color ramp here. So I need to set this to Z, maximum height, maximum value. We're going to export a raster and the heights. So we can do that to the desktop. We'll just call this lidar.tiff, not a very creative name. And then we can drag that into ARC when it's done. So here is the, oops, we'll refresh this. Oh, looks like that file didn't save to the right spot. Let's do this again real quick. Oh, it saved to the temp directory here. Okay, that's what happened. So there's our raster.tiff, and we can bring this into ArcGIS. Okay, so if we zoom into this, the problem with this data is that there's no real location information attached to it. So it's important that that gets set correctly to be able to use this. What we want to use to do that is a defined projection. But we don't know what projection this is supposed to be in. You can actually figure that out with a tool that we'll cover in a future lecture called LAS Info to look at the header information. But we happen to know that in this case, this is going to be the same as the DEM file that we're interested in. So if we bring in this DEM data, that was produced along with that same LiDAR data set, we can use this to reference the other one. So if we look at the properties of this one and look at the metadata, we can look at the spatial reference, and we can see that this one is actually set to NAD83, State Plane, Virginia. This is a Lambert conformal conic. We've got an EPSG code of 2925, which is a nice way of keeping track of this stuff. But now that we have one that we can kind of borrow off of, we can use that to do the projection. So if we use define projection, this is going to overwrite or define the projection. So it's not reprojecting the data, it's doing a new assignment. And you'll see that this coordinate system is set to unknown. And what we want to do is just use something else to do this projection. So we'll hit OK. Now if everything's gone to plan, we should be able to zoom in to our raster layer, and it should be referenced in the right location. So that looks like it came in pretty neatly. You can sort of see the building lines are all sort of lining up pretty well, but you can verify that. Okay, just a quick lesson on defining projection for rasters that are produced in CloudCompare.